Alright, hello and welcome to the PowerPoint about velocity and graphing. So let's say you have a football that starts at the 20-meter line, but it moves to the 50 in 2 seconds. Remember, these are meters, not yards. It's a metric football field, right? What's the velocity of this motion? Well, you remember that the velocity formula is the change in position over the change in time, and then you need the direction there. Otherwise, it's just a speed. So you say, well, ends at the 50, starts at the 20. So the final position minus the initial position over the final time minus the initial time, and you get 30 over 2, which is 15 meters per second, and then forward is your directional marker. You could put a positive there if you wanted to. So positive 15 meters per second is the football's velocity from this word problem. But you won't always get a word problem. Sometimes you get a graph. It starts at the 20, and it ends at the 50. It takes 2 seconds. Now notice that this graph has exactly the same information that the previous slide had. You can figure it out. I don't give you a word problem, I just give you a graph, but you can pull everything you need out of it. So the velocity is the change in position over the change in time. So I know at the end, it's going to be at the 50. At the beginning, it's at the 20. And the change in time is 1, 2 seconds. So what you get is 50 minus 20 over 2 minus 0 plus 15 meters per second. But what you should notice is what I did was I took this 50, which is a y value, this 20, which is a y value, this is y at the end, y at the beginning, and then I took this 2, which is an x value, this 0, which is an x value, that's x at the end, this is x at the beginning, and I took the difference and divided. That's the same thing as the slope. So when you have a position versus time graph, the slope of the graph is literally, mathematically, the exact same thing as the velocity. Sorry about the bell. You remember how on a position versus time graph, a negative slope means that something is moving backwards? Well, that's what the positive and negative mean on the velocity too. Remember, positive is a symbol that means forwards, negative is a symbol that means backwards. That's why we use these symbols. They naturally pop out of the formulas if we put in the right numbers. So if I give you just a position versus time graph with numbered axes or numbered points, you should be able to find mathematically the number of the slope. They're the same thing. Number of the velocity, not the slope. My bad. They're the same though. So this is the slope formula in case you forgot. y2 minus y1 over x2 minus x1. This is just me proving more in depth that slope and the velocity are exactly the same. So y is position. So wherever you see the y here, you can substitute position. Wherever you see x, you can substitute time. So this is what you get. That's the change in position over the change in time, which you remember is the formula for velocity, right? As long as you remember the positive negative directional sign. So if A is equal to B is equal to C, then that means that A is equal to C, right? So if slope is equal to this, which is equal to this, then they are equal to each other. That's a more in-depth mathematical proof if you wanted one. Also, you can just think about the units. This is the graph of position versus time, right? And to get the units of a slope, you do the units of rise over the units of run. So the units of rise are meters, because that's the y over here. The units of run are seconds, because that's the units down here. So meters over seconds, which is the same as the units for velocity. So what's the velocity of this motion? Let's practice. Here's a graph. I don't tell you what happens. Can you figure out the velocity? And the answer is yes, you can, because it's the same as the slope, right? The change in position over the change in time, which is the same as y2 minus y1 over x2 minus x1. So y2 is 30. There we go. y1 is 60. So 30 minus 60. Over x2, I end at 3 seconds, and I start at 0. So what I get is negative 30 over 3. Hopefully you remember that a negative 30 meters means that I move 30 meters backward. So your answer is negative 10 meters per second. That's a velocity. 10 meters per second backward. If you have a graph with a bunch of different parts, you can just get the slopes of those parts. So this is somebody moving backwards for a while, then forwards, then they stop, and then they move forwards again. You can figure out the slope by doing y2 minus y1 over x2 minus x1. Simplify it down. Negative 20 meters per second. That makes sense, because we're going backwards. For section B, you take y2 minus y1, that's 40 minus 20, over x2 minus x1, which is 2 minus 3. The slope of this middle part is 20 over 1, which is 20, positive 20 meters per second. That's our velocity. Section C. You can see that they're not moving because it's horizontal, but if you want to calculate it, you can. Right here, the y, the position is 40. Here, the position is 40, so the difference is 0. 0 divided by anything is 0. They're not moving. And then finally, this last section of the slope. Do the same thing. y2 minus y1, y2, y1 minus x2 is x1. Divided by, not minus, sorry. And what you get is 20 over 2, which is positive 10 meters per second. I would always put the positive and negative on the velocities here, just to let you remember that it's a directional sign. But if you leave it off, that's okay, as long as you remember that a positive is there.